In this video, we're checking out the Artillery Sidewinder X2, a large format i3 with some impressive features and a successor to one of the more impressive 3D printers in recent memory, the Artillery Sidewinder X1. That naming though, please YouTube, this video has nothing to do with any kind of weaponry, so please no, don't demonetize me. Demonetized. How's it going, guys? Angus here from Maker's Muse. In 2019, I reviewed the Sidewinder X1, which impressed me with its fast heating AC print bed and high flow capable volcano style hot end. But it was let down by unreliable ribbon cables, questionable cable strain relief, and a few other poor design choices. After a few modifications and repairs, I did however get it working very reliably, and I gave it away to a friend who still uses it regularly. And I kind of regret giving it away. So I had very high expectations for this machine. The printer comes with a decent hard copy manual plus a PDF one on the USB stick, and it's really quite good. Assembly is very straightforward, with the two main assemblies slotting together and securing in place from the bottom with 4 bolts, and then you just attach a few stepper motor and limit switch wires, but you do have to be very careful to line up the PCB fingers on the gantry with the slot on the frame. This is part of Artillery's new ribbon cable design, as the previous plugs were a common failure point. And this feels like a much more permanent solution. There's also this unused plug, and I have no idea what it's supposed to do. The manual doesn't even reference it, so I don't know. I also want to thank Artillery for shipping this printer with a properly shielded and grounded mains cable, instead of these things some other companies send out, which don't meet Australian standards. I don't know what plugs for other countries look like, but I'm happy to see this here. It's pretty evident at first glance that this printer is an evolution of the X1 and not a total redesign. There's a lot more refinement, as well as a lot more injection molded plastic, which for the most part, I don't mind as long as it's functional, but it blows my mind that it's more cost effective to make this top rail out of plastic than just another slice of V-slot aluminium. Mechanically, this large plastic part holds bearings for the belt, synchronized dual lead screws, as well as slots for the spool holder. And check this out. This part would have been a large but fairly conventional 2-part injection mold, but they had to add text to the front, and they had to do that using a side core in the mold. Just for branding, they made the mold more complicated. Crazy. The X, Y, and Z axes ride on V-rollers, which came correctly adjusted from factory, and plastic aside, it's the same overall design as the X1, with a print volume of 300 by 300 by 400 millimeters high, and an AC heated print bed with that now quite familiar ultra base style glass surface, which is fixed in place and you can't remove it. This is good and bad. There's no clips that get in the way of the print like some other printers have, but you cannot remove it. It's glued in place, so you have to wait for it to fully cool down for the prints to come off, and when it does finally wear out, which is a long time away, I'm not exactly sure what I'm going to do. Like before, this printer has a Titan style geared direct drive extruder, and that means there is no Bowden here, so you can push out filaments really fast through the volcano style hot end, and it does also handle flexibles, which is pretty nice too. It's a 24-volt system with Artillery's own Ruby 32-bit control board and silent stepper drivers, and it really is quiet, with only a little bit of fan noise during operation, and really all you hear is those rapid travel moves, and even they are quite reserved. The interface is pretty much identical to the previous generation with a color touch screen, and connectivity is through USB or micro SD. There is no Wi-Fi connectivity unfortunately, but you could add it yourself with something like Octoprint, connected to the USB Type-B port on the side. There's a range of comfort features as well, such as filament runout detection, which I've unplugged currently, but you just plug it in and it works really well. And it's mounted up here near the spool instead of just before the extruder like on some other printers, which means it actually works when you do run out of filament and you need to withdraw it. You actually have a fair amount of space to do so. There's also power loss recovery, but with a print surface like this, it needs to be heated for prints to stick, like 60 degrees Celsius or so for PLA, which means you only have a limited window for the power to come back on, or your prints will just come off it. But arguably the best new feature in the X2 is mesh bed leveling with a contact probe cleverly integrated into the extruder assembly. It's a cloned Ant Labs BL-TOUCH, which has been heavily modified in its appearance. Despite this feature though, the bed still has 4 leveling screws and a more standard semi-assisted bed leveling process, where the hot end will move to each point and you adjust it with a shim or a piece of thin paper. But the thing is, that's not what adjusts your nozzle height. So what I actually recommend is you do that first and then do your mesh leveling. And then, this is really important, when you do your mesh bed leveling, you also have to set the Z offset. So yeah, don't meticulously try to do it manually because it'll be wrong. The probe itself is actually how it homes the Z axis and thus determines the offset through Z baby stepping. So I recommend setting it way far away to start with and then bringing it closer gradually on a test print. Or you'll do what I did straight away and instantly jam that nozzle into the glass plate before you can react. Yay! That glass plate, by the way, has a mains powered bed heater, meaning it warms up really quickly. But it also means there's the added danger of mains voltage, which is dangerous, running through a wire to a constantly moving surface. The X1's bed cable design was insufficiently designed for that constant movement, but this new design has a large flat cable running along a specially made channel with a decent strain relief, and in my opinion is a way better long-term solution. Okay, onto the test prints. The USB had a demo cube, and like previous generations, they weren't shy of ramping up print speed, which is always confidence inspiring, and it looks good, but there's also like some black filament bleed into it, which is also good because it's proof that they actually test their hot end assembly before shipping the printer. It printed totally fine. So I started slicing some of my own models using a custom pressure slicer profile based on my old one for the Artillery Sidewinder X1. They do package Cura 4.1 on the USB as well, and they recommend the X1 profile for that if that's more your thing. They both work totally fine, it's just whatever you're more comfortable with. I just prefer pressure slicer personally, so I'll link my profile below. But yeah, you can use anything to slice and send to this printer. This Geir Anderson cat in red PLA printed great with no stringing or extrusion zits, which is pretty impressive considering I'm only running 0.8 millimeters of retraction, and the surface is very accurate, though there is a subtle texture to it and a little bit of that Z inaccuracy with the extrusion width that we kind of saw in the X1. But we'll come back to that. Clearances are very accurate on this printer, and I pushed it to the limit with a range of challenging print-in-place models. This sliding puzzle prints all in one go, and the goal is to unscramble the 3D printed picture. There's a link below for more info. The bottom surface is almost perfect, except for some small evidence of lifting in 2 corners. I print PLA at 60 degrees C on this style of glass bed, and maybe those areas were a little bit too far away, or maybe the plate was a little bit dirty, but all the parts did print perfectly and they all moved smoothly, independent of each other. On my clearance gauge, I was able to get down to 0.15mm gaps, but only just. It did require a screwdriver to snap the part free, and it was actually still slightly welded in one spot at the 0.15, where the perimeters just barely touched and fused, so there's definitely a little bit of inaccuracy with those extrusion widths. Lastly, these are prototypes for a whole new accuracy test I've been working on called the Clearance Castle. The original clearance gauge takes quite a few hours to print, so I wanted to develop a quicker test as well as a much more challenging complex model, which is more of a test for those more confident in their printer's abilities. The clearance tower has a taper from 0.5mm gaps all the way up to 0, and the printer can clear well past 0.15 before jamming up towards the top, which is a very impressive result indeed. I can't wait to share more about the clearance castles with you guys because it still needs a bit of work, and I've been printing a lot of tests, so don't forget to subscribe or you might miss it. Okay, so what about something bigger? This Banjo Dino sculpt by Frame World on Thingiverse is one of my all-time favorite sculpts. It's full of texture and has some really difficult to print details, such as these backward-facing spikes, which need support material. Pressure Slicer wanted to put tons of supports in, but I reduced them down to where I felt they were most critical. Unfortunately though, when you swing a print bed this large around quickly with tall, unstable supports, they tend to fall over, and heaps of them did. I think a sheath around the supports using this setting in Printer Slicer would have helped. I'm sure there's a similar setting in Cura, but the larger and taller you print on a moving bed printer, the more unstable things get, and that's just how it is. Still, remarkably, the print actually looks wonderful, even with all those failed supports. There's only one area of obvious failure, which is inside the mouth, but otherwise, it's a really, really good, highly detailed model. Again, this printer prints up to 400mm high, but it comes stock with a 0.4mm nozzle, which means that is days upon days of printing to get that high. And I wasn't really prepared to do anything bigger than this. However, people, in my opinion, are most likely to benefit from the larger print bed, like I did with this huge array of maker coins. These coins printed awesome. They're in a red PLA, and don't worry, I do have a plan for what I'm going to do with all these maker coins I've been printing recently. But what about that odd surface texture that some of these prints seem to suffer from? Well, this simple print demonstrates it pretty clearly. With the text, ghosting is present, but it's pretty minor and only slightly worse along the y-axis, but there is visible striations across the model, even on the large, simple, flat areas. I don't think this is Z-banding or even imperfections from the V-rollers, but instead I reckon the volcano-style hot end that Artillery uses isn't as accurate in its extrusions as hot ends with a much smaller melt zone. Smaller prints like this 20mm tower do come out much cleaner, but with the longer extrusion paths like on this model, it's very obvious in places. But it's also worth being mindful of how I'm intentionally using bad viewing angles in this B-roll to show these flaws with lighting, because you can easily manipulate things. Look, perfect printer, bad printer, good print, bad print. Lighting is everything. Artillery are incredibly proud of these odd-looking couplers, which they've patented apparently, and it's possible they do assist with Z-banding resulting from bent lead screws or something, but I'm unsure if they're actually also contributing to this surface finish or not. If you'd like to see me remove them and do some side-by-side tests, let me know in the comments, because I am pretty curious to see if they're actually helping or hindering. But extrusion accuracies aside, this volcano-style hot end is capable of pushing a ton of filament, but at the moment I only had a really poor quality 1mm nozzle that fitted it, and I did a few tests, and yes, they printed pretty quickly, but it's pretty clear that they're not all that good. They're very rough. So I think the sweet spot for this machine is a 0.6 or 0.8mm nozzle. That's what I fitted to the X1 before I gave it away, and that meant this machine could print really large models quite quickly with a fair amount of detail, running like a 0.3 or 0.4mm layer height, but much faster than something you'd do with a 0.4mm nozzle. So definitely something very useful to have on hand when you need to do models like this, or even larger, that you don't want them to take days. And in a little gift pack that Artillery gives you, they give you a spare ribbon cable, but they also give you a spare nozzle as well. So I think it'd be really cool for them to just package a spare 0.8 or 0.6 instead of a spare 0.4, which I really do think is a bit too small for the capabilities of this printer. I really liked the Sidewinder X1, but I was let down by its unreliable ribbon cables and quality control issues like the infamous snapping extruded tension arm, which I think everyone's eventually snapped, even the one I had. When I gave it away, it snapped on the guy I gave it to. But look, Artillery had two options. One, they could just bury the design and release something totally different under a new name and try to hype it up, like some other companies, or they could have gone back to the drawing board and fixed what was wrong. And there's been several versions of the Sidewinder X1 already with various changes, but the X2 does really feel like a product that was properly designed and tested and then released, even if a lot of that testing was done on the users of the X1. The gaudy top plastic rail is pretty ugly, but it's functional, and I'm happy to note that there is key mechanical parts of this machine that are still made of metal, like these components at the back that hold the Z-axis V-rollers, and I think they tension them as well, and they mate to the dual lead screws. As far as I can tell, these parts are die-cast metal, like magnesium or aluminium or something, and then they've machined them. This is the first time I've seen custom die-cast metal parts on a hobby-level 3D printer. If you've seen it before, let me know in the comments, but it's honestly pretty cool. 3D printer prices do seem to change with the wind these days, but Artillery has the X2 listed for $489 US currently. And 3D printers online here in Australia are selling it for $700 Australian with free shipping, which when you consider the conversion rate is actually really competitive. At the price point of this machine, you could instead go for two budget i3s, like an Ender 3 or similar, or an i3 and a budget resin printer, which is also like a really great way to get into 3D printing with not very much money. But this machine will print bigger, better, and faster than any of those other options with a better overall user experience, in my opinion. I'm not a fan of the print bed being permanently fixed or the awkward filament holder, but they do work, and the Ultra Base style glass is pretty durable. I don't see I'm gonna have to ever replace that pretty much. But personally, I'm going to equip this printer with an external spool holder and PTFE tube to the hot end, so I can run like 3 kilogram spools with a 0.8mm nozzle for some truly large models in my future projects. So if you'd like to see that, then maybe consider subscribing here on Maker's Muse, where it's my aim to empower your creativity through technology. If you'd like to pick up a SIDEWINDER X2, you can find links in the description below. Full disclosure, Artillery did provide this printer to me free of charge for purpose of review. When I'm completely done with it, I'm going to just donate it again like the X1, and no money has changed hands, and all thoughts and opinions are my own. Thanks for watching, guys. Bye.